This video is in continuation of my previous video about the finding out the two important things. One is about the origin point, and second thing is about the finding out the rotation axis vector. Okay, so now let me explain more here. Okay, so now you can see here that this impeller is inclined at the some angle. Okay, so you can like make an angle with the vertical or maybe with the horizontal. It doesn't matter actually. So let's say this angle is theta. Okay, whatever it is. Now, what we need to find out, actually, we need to find out the origin point. And what I did is that I placed the origin point on just on the bottom side of the impeller's hub. Okay, somewhere here. I will show you that thing. So one point is here. Let's say this is the point A. Okay, this is the point A. This point A is the origin. And second point you can place anywhere. Here, 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 even on the bottom side, but the only thing is that wherever you put the point B, so the vector will be like represented by the point A to B, the position vector A to the B. Okay, so this AB is a position vector, and whenever you want to give the like rotation axis direction, minus or plus direction, so you should point your thumb along the like a vector, means from A to B. Your thumb should be pointing now upwards. If you take the vector BA, in that case you will put your thumb on the downward side. And then based on, let's say the thumb is on the like it's the pointing topward side like this. Then you wrap your four fingers. So definitely if you wrap your fingers, they will go in the anti-clockwise. So this anti-clockwise is going to be your direction. So now this is the positive direction. Then the anti-clockwise direction will give you the, if this is rotating along the anti-clockwise, then the direction will be positive. But if your directional rotation is the same, that is upward, and but your rotor is impeller actually is moving on this side, then you have to put the minus value. Let's say minus 500 rpm, r plus 500 rpm. Okay, so this thing you should be very much careful. Number two thing is that I have shown you the last time that we need to find out the position vector, that is Li plus Mj plus Nk. Okay, position unit vector. So unit vector actually will identify the your direction. So we need to put the two things here in the Fluent, and I will show you on the panel. One is that you have to put the like a first point or the rotation axis origin point. Now this origin point again, not necessary it should be on the 0 0 0. I have placed this point 0 0 0, but this point can be anywhere. So you have the like a coordinates for A, x1, y1 and the z1, and for point B, this is your origin actually. And point B is the x2, y2 and the z2. So in the previous video, I have shown you that you can find out your unit vector by the formula. For example, the cos of alpha, which is equal to L, is equal to the x2 minus x1 divided by the magnitude. Okay, x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And similarly for the cos beta and cos gamma, this will be the L, and then M, then N. This will be the like y2 minus y1 divided by same magnitude. But the thing is that now I want to will explain here is that not necessary that you should be using the unit vector. You can only use this vector as well. Okay. So for example, you can, and this will give you same value because the x2 minus x1 will be some value. If we divide by magnitude, this will be less than 1. So it doesn't matter actually for direction values. So you can simply put the x2 minus x1 for the first value, y2 minus y1 for the second value, and then the z2 minus z1 for the third value. Okay. So now let me give you the idea. Let's say I'm going to like save this file with some new name, let's say ABC, so that I can demonstrate that we can like have some different origin Okay. So let's move this whole thing to the sum like uh, let's make it translational. Okay. I want to keep the like here. Maybe you can like move here and slightly here as well. Okay. So now this is very random location. Okay. So let's hide the outer domain here and concentrate on the inner domain. Okay. So hide face. And here I'm going to place a point. Now this point is on the like a bottom face, but it's not going to be on the 0 0 0. So let's put the 1 point here. Second point you can place along the axis anywhere, doesn't matter. Okay. So like for example, this is axis. So you can place the point anywhere. For example, if I make a sketch on this plane, okay, and then I make the point over here. This can be here, 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 anywhere. Okay, let's say we are putting the point here. Okay, this is now a very random thing. Okay, so now we have the 2 points. Okay, so first point is here. Okay, now also I will be writing down the like its coordinates. So I will now place these two things side by side. Okay. Okay, now from the design menu and the move command, click on this point, right click here and click on the XYZ. Okay, so here the just a minute. Okay, so the origin is here. So x1 is equal to now 593.72. X2 is equal to sorry y1 is equal to 696.27 and the z1 is equal to 562.36. Okay, second point, this is a point A. Okay, the second point is the point B. Point B is here and here the x2, y2 and the z2. Okay, now finding out the value of the second point. Second point's value are these ones. Okay, so 548.08, 891.2 and 611.58. Okay, let me confirm the like these points. 593, okay, 696 and second points are these ones. Okay, I'm just confirming again and again. Okay, 548891 and 611. Okay, so now I didn't make the geometry like a meshing and everything according to these coordinates. These they are on the my origin was on the 000, but just I wanted to show you that how this can be done. Okay, and there's no need to actually find out the like a unit vector. Even you can just provide the x2 minus x1, y2 minus y1, and z2 minus z1. So now these values will become x2 548.08 minus 593.72 is 45.64. Okay, 45.64. 45.64 minus. Second value is the y2 minus y1, 891.2 minus 696.27. It's a 194.93. And the third value is the z2 minus z1, 611.58 minus 562.36. So 49.22. Okay, so now these values I'm going to input here. Okay, where I'm not going to put it over here, but this will work very well if the new mesh was based on the these two geometry locations. Okay, so in the safe zone conditions and in the inner domain, which is rotating at the some RPM. Okay, so the origin will be this one, the first point, point A. This one will go here, and the rotation axis direction vector will be this one, 45.64 minus 194.93, 49.22. Now let's say if I go with my previous case, okay, which is currently loaded in my Fluent. So that is over here. Okay. So now I need to put the origin, which is already 0, and the second one is this one. Okay. So x2 minus x1 will be same value because origin is 0. y2 minus y1 will be same value, this one, and z2 minus z1 will be same value. Okay. So now if I put the values instead of these values, if I put the minus 27.94, 119.32, so there's no need to actually find out unit vector, but this looks better actually. That's why I did it. But you can simplify the things and you can just keep the x2 minus x1 here, y2 minus y1 here, and z2 minus z1 here. Okay, and apply. And to just to confirm this thing, actually you have to preview your motion, and this will give you idea if this is in the direction it is moving properly. Then the upper part shaft's upper part is in the outer domain, and the shaft's smaller part is with the impeller. If they don't align together, they don't rotate along the proper axis, you will see after some time this impeller will not be aligned to the remaining part of the shaft. This is very a very fast check about these things. Okay, so preview mesh motion and display. Okay, this should give you idea. So this impeller in the green should always be aligned with the remaining part of shaft, which is with the outer domain, which is in the yellow color, and they should be always connected. Okay, not connected mathematically or from the mesh point of view, but from the looking at these two parts. Okay, so just now give the let's say we go with the number of time steps with the 4, 5. So you can see the rotation 5 times. Okay, This is just to confirm. This is the checking that our rotation axis direction and the origin is properly entered into the fluent. Now see, yellow part and green part, they are still the same line. Okay, they are exactly mating at the same location. Impeller's rotator's blade is here. Now after the see here. Okay.